All right, everyone. So now we're going to be going over part B of the arrays question. Suppose we have the method equal rows, which takes an array of arrays and makes sure that the sum of each nested array is the same as the sum of the first array. If the sum of an array is not equal to the first, that array is replaced with a new array that has completely identical items, but with an extra element at the end chosen so that the sum of the new array is equal to the sum of the first array. You may assume that the R is non-empty. And a quick visualization of this is as follows. So assume you have R, which is this 2D array. You have the first nested array, which has a sum of 6. And then you have 3 other nested arrays whose sums are 20, 0, and 0 respectively. What we want to do in equal rows is, because each of these rows sums are not 6, we need to add an element to each of these. We need to add an element to each of these arrays so that the sum of each array can become 6. So for 20, it would be -14. And because this is 0, this would become 6. We add 6 at the end. And then because this is empty, we would add 6 at the end here. And so that is R. That is what equal rows does. But now here we are working with the buggy implementation. There are 4 bugs. For each bug, note the line number, give a description of the bug, and suggest a fix. For both the description and the fix, please be concise. You may explain with the mix of code and reasoning. So let's go over this implementation. And before we actually go over this implementation, let's think about how we can actually approach this. And it's actually pretty simple. So first, what we want to do here is find the sum of the first array elements. So and then what we want to do is go through all the other arrays and find the sum and find each sum of those. And then finally, what we want to do is replace each array with a different sum with a new array. Sorry if you guys can't see that. Let me move this a little bit. Yeah, so I'll just go this up here. So what happens here is we replace each array with a new array with a new element. And that new element will help the sum of the new array be equivalent to the sum of the first array. So I'll get rid of this. And now let's get started. And so let's go through this method and see. You have int needed sum is equal to 0, and then for every integer in our index 0, which is basically the first nested array, you add up each number in the array and add that to needed sum. And that would be the sum of the first array, and that is sort of what you want each next array to be equal to. And so this is a good start. Then you have int sum equals 0. And then you have another for loop here, and it looks like it goes through every single nested array. And so what we can assume happens here is that we find the sum of each array, and what we do there is then create a new array if needed, and have with the new element at the end that makes the sum of the new array equal to the first array. And already here we can notice a problem. Because each iteration of the for loop is for each array, that means we want to sort of reset our sum, have a sum variable that is unique to every single array. What we have here in line 6 is that the int sum equals 0. That's outside of the for loop. That means that we're going to find the sum of all the elements in the 2D array. And that is not what we want. We only want the sum of the actual elements in each nested array. So that is our first bug. So it would be line 6, and then for loop finds the sum of all the elements in the 2D array. And the quick fix is to move the sum counter in the second for loop. And so that's a quick fix. Then we can break down the rest of this for loop. So it looks like it goes through each nested array, as I said earlier. We have inner array, which corresponds to our index I. So that would be the nested array we're looking at currently. And then it looks like we go through each integer in the inner array, and we add that to sum, assuming now that sum would be moved inside the for loop. Then we have if sum is not equal to needed sum. This is correct because, as the question states, we only replace each array if the sum is not equal to needed sum. So now we have int new array is equal to a new integer array with a length of inner array dot length plus 1. This is correct because, as we know, we have to have an element at the end of the inner array that sort of will help our new array come up to a sum of the first array, or needed sum in this case. And so the next line is system.array copy inner array, comma 0, comma new array, comma 0, comma new array dot length. Now, if you notice here, this is actually an incorrect use of the array copy syntax in this specific case. Because here what we have is inner array for the syntax of array copy. Each parameter is as follows. We have inner array, which serves as our source array. We have 0, which is the starting position of our source array. Then we have new array, which is the destination array. Then we have 0, which is the first spot of the destination array. And then we have new array dot length, which is the number of items that we need to copy from the source to the destination. Now, if you notice here, new array dot length is inner array dot length plus 1. And remember that we are copying that many elements from inner array. But as you notice, there are only inner array dot length elements, not inner array dot length plus 1 elements, which means that we are copying way too many elements. And this would result in an error because there is no like one more element that we can copy. So this is our second bug. That would be line 14. And the description would be array copy will try to copy new one more element than provided in inner array. And the quick fix to this is replace new array dot length with inner array dot length. And so now let's move on to the next line. New array at index new array dot length minus 1. This is correct because that's the last element of the array, is equal to sum minus needed sum. Now let's see if this part is actually correct. If we go back to our visualization here, where this sum is 20 and we want to make this to be 6, we add the element of negative 14 to it. If we go along with the logic as specified in the buggy implementation here, which is sum minus needed sum, or the sum of the current array minus the sum of the first array, we would then get 20, we would then do 20 minus 6, which is equal to 14. And that means we would add 14 to the end of this. However, if you see that 20 plus 14 would be 34, not 6. So instead of doing sum minus needed sum, as you can see here, we would do needed sum minus sum. And that can be simply explained here as well, because if you have 20 here and you want this to be 6, you would do be 6 minus 20 to get negative 14. And when you do 20 plus negative 14, that would be 6, which is the sum of the array, which is the correct sum that we want. And so as a result, that would be our third bug. Line 15, and it would be the last element of the new array is the wrong number. And so the quick fix is do or set new array dot length -1 to needed sum minus sum. And so that is our third bug. Now our fourth bug will probably be found in line 16, since that is our final error, but let's just take a look at it in case. So now you have inner array is equal to new array. And remember, when we are working with objects in Java, in this case, array is an object, we change, whenever we have something like this, we simply change the pointer of the variable rather than actually changing the values of the variable itself. So when we say inner array is equal to new array, inner array, which was originally pointing at our index I, or the nested array we're looking at in this current iteration of the for loop, that inner array will now point to new array, which is the new array that we've created. And the difference here, and this is technically not correct, because what we want to do is have new array become new array enter the existing array, and that we don't have here. And so as a result, what we need to do is make sure that our new array is set to the specific R index I, so that R index I will now point to the new array. And so, yeah, line 16, the existing 2D array does not have the new array and does not have the new array pointed to from R index I. And so the quick fix is replace inner array with R I, and then this successfully will change the pointers, which is what we want. And so we finally found all 4 bugs and in this buggy implementation, and we are done.